Okay, Module 6.2, Sign Language. Here for our warm-up, we have a number line that has a series of dots on it. Each dot represents a number. Some of them represent the same number multiple times. So what I would like you guys to do is to determine first the median, and these all represent ages, okay? Determine the median and then estimate the mean, and then create an ordered stem and leaf display. So a stem and leaf display is a line. Let me give you guys an example here. So if I were to draw a line and I wanted to represent the, let me make this thicker, represent the number 25, then I'd put a 2 right here and then a 5 like this. Okay, if I wanted to represent the number 27, the 2 is already there, so I would just put a 7 like that. If I wanted to represent the number 30 multiple times, I'd have to incorporate another number and then go 0, 0. Okay, do you guys get it? Good. Then, after that, make a histogram. A histogram is basically a bar graph, but instead of having categories, it has bins that have a number range. So in this case, we have, well, I don't know, we could just do by tens. We could say from 20 to 29. And so we could look here and say, okay, how many numbers, ages, are from 20 to 29, and we could say 1. So we would just indicate that by having 1. And then, like, let's say over here, we have 30 to 39. How many are in that range? So we have 1, 2, 3, 4, 5, 6, 7. Not the 40, so we'd have to go up to 7. So 1, 2, 3, 4, 5, 6, 7. And you guys get the idea. Okay? Good luck. Take a couple minutes, and we'll take it from there. So what I got for the median, if you just start from either end and work in, median age is 43, and then after you establish the mean, it's about 43. And then when it comes to the stem and leaf, we put all the initial values, okay, the tens place, and then see this number right here. This represents a 29, so we're going to put a 9 like this. There's no other numbers, so then we're going to move on to the 30s and then start incorporating all of those numbers in there. Then the 40s, then the 50s, and 60. Okay. Now when it comes to the histogram, I did age, and then on this side, however many people. So we got all the way up to 8, I believe. So 1 for 20 to 29, 7 for 30 to 39, 8 all the way to 49, and 3, then 2. How'd you guys do? All right, so we're going to continue here and look at a box and whisker plot. So if I was to give you guys these numbers right here, in order to create a box and whisker plot, we first need to put them in order. So why don't you guys put them in order now? Okay, so once we have them in order, we're going to try to, or use that value, we're going to find the minimum value, the maximum value, and then also we need to find the median. So once they're in order, we got the lowest and the highest, or the maximum. All right, so the lowest number and then the highest number, and then our median is 84. That's quartile 2. Now to find quartile 1, it's not going to be including the median. Okay, it's just going to be the median basically of this section right here. That'll be quartile 1, and then this section right here. Okay, so since we have an odd number of numbers in our set, we don't include the median to find the first quartile and the third quartile. So basically, for quartile 1 and quartile 3, we're going to take the median of the first section, which is going to be, since we have two numbers, we're going to add them together, divide by 2, we get 76. And then here we have, well, that's going to be 91. And then we're going to go ahead and put those onto a number line. So make sure that you guys create the number line first before you create your little box and whisker. Some people try to create the box and whisker and then put the number line accordingly, and it just doesn't work out. So here, do a number line like so. And then since our lowest number is 67, we could say that this is, we'll say 60, and then we'll just increase by 5s. 65. Then this will be 70, this will be 75, this will be 80, this will be 85, and we got 90, 95, and we got 100. Okay, so our lowest value, which is 67, we'll go ahead and put that about right here. Put a dot. our highest value, which is 95, which I got it right here, a dot. Our median is 84, so 84 would be a line that goes like this. And then our first quartile is 76, which will be about right here. And then this one is 91, so we put a dot like this. Draw the box, put the whiskers, and you got yourself a box and whisker plot. Not bad, right? All right. Now that we understand that and we got our box and whisker, I want you guys to take 5 minutes and try the best to your ability complete the unit circle. All right, so how I would approach the unit circle is start here and say that that's going to be 30. Okay, we understand that. We did that when we did our proof quiz. We know that this is going to be 30. And we remember that if this is 30 degrees, opposite is the y value, and the y value is 1/2. We proved that, and then the x value is going to be radical 3 over 2. So we know that this is 30, and we also know that the ordered pair for this is going to be radical 3 over 2, comma 1/2. All right. Now, I'm going to go back to the degrees, because from here, we're going to wrap around. We're going to skip the 45 degrees and go to 60, then do 9, 90. So just go 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and then 360. All right, so that's how we figure out what all of the degrees are, at least initially. Okay, now with that in mind, don't forget that here we also have 0 degrees as well. Then off to the side, what I want you guys to do is draw pi, which is half of the circle, and then cut it into 6 pieces. And if you cut it into 6 pieces, this is 1/6 of pi, this is 2/6, this is 3/6, 4/6, 5/6, 6/6, and then if we continue all the way around, then this guy would be, well, this is 6/6, this would be 7/6, then this is 8/6, directly down is 9/6, then this is 10/6, this is 11/6, and then this would be 12/6. Then when we bring it back to our unit circle, we're just going to reduce, as I make a little mark here. So this would be, well, this would be 0/6, so 0 pi. Then this is 1/6, or pi over 6. This is 2/6, which reduces to pi over 3. This is 3/6, which is pi over 2. This is 4/6, which is 2 over 3. This is 5/6. Make sure that you guys are putting the pi on the top there. This is 6/6, or just pi. This is 7/6, 7 pi over 6. This is 8/6, which reduces to 4 over 3. This is 9/6, which is 3 pi over 2. This is 10/6, which is 5 pi over 3, and this is 11. That's 11 pi over 6. Okay. Now from here, I would continue with my ordered pair that I had. Now remember, this is also a 30-degree angle, so that means that opposite of this is the 1/2. And then right here, since it's in the second quadrant, this is negative radical 3 over 2. So it's going to be a lot similar to what we have here, except this is going to be now a negative x value of negative radical 3 and then over 2, and then a positive y value. Now the one at 210 will be similar, except now both of them are going to be negative. And then in this quadrant, I'm going to go ahead and erase this. Okay, in this quadrant over here, we have a positive x value and then a negative y value. Okay, and let me close that up. All right, now 60 and 30 are kind of related, and how they're related is that the x and y just kind of swap here, almost like inverses. So up here, this is going to be negative 1/2, comma positive radical 3 over 2. And then down here, this will be negative 1/2, negative radical 3 over 2. This will be positive 1/2, negative radical 3 over 2. All right, so we got almost everything except for the 45-degree angles. So let's do the 45s. That's 45. And now from here, I mean, the difference between 30 and 45 is a 15-degree spread, right? So we know that if we needed to, we could just add 15 degrees here to 120 to get 135, and then add 15 degrees here to get the 225, add 15 degrees here to get 315. Okay, and then from there, pi, when it comes to pi, you're going to be cutting it into fourths. So this would be 1/4 of pi, or pi over 4. This would be 2/4. This would be 3/4 of pi. This will be 4/4. This is 5/4 of pi. And then this is, what am I doing? 7 pi over 4. There we go. All right. And then when it comes to the ordered pair, remember with our proof of 45 degrees, that x equaled y. Radical, that's a 2. Radical 2 over 2, comma, radical 2 over 2. And then over here, this is radical 2 over 2, comma, radical 2 over 2, except the x value is negative. Over here, this is negative, negative. Radical 2 over 2. Okay, and this guy as well, this will be a positive radical 2 over 2, negative radical 2 over 2. All right, so that is all of the unit circle except 4 things. So we've got everything except the north, south, east, west coordinates. So remember, this is a unit circle that has a radius of 1. So this ordered pair is going to have an x value of 1, comma 0. This one's going to have an ordered pair of 0, comma 1. Over here, this will be negative 1, comma 0. And then down here, this will be 0, comma negative 1. Okay, now don't forget that also within the first quadrant, all of them are positive. Over here, just the sign and the things that are related to sign down here as well. Now, I'm going to go into that a little bit more. This chart right here, if you guys were to look at all the values that range from here, I'm going to actually highlight this. If you look at all the values that are in the first quadrant, which are right here, all of these are positive. Okay, and then if you look at these values that are right here that are in the second, so this is first quadrant, okay, so we'll say quadrant 1, and then in quadrant 2, all of these values, what are the only ones that are positive? The only ones that are positive are sine, let me make that a little bit thicker, sine, and its doppelganger, cosecant. So over here I'm going to write sine and cosecant are positive. Okay, and then in this quadrant down here, this is quadrant 3. Who's positive in this? Well, gosh, since it's quadrant 3, both of them are negative, right? So the only ones that divide the x and the y, these guys, right here too, and here. So just the tangents. So this is tangent and cotangent are positive. And then in the fourth and final quadrant, quadrant 4, the ones that are positive are cosine and whatever's related to cosine, which represents secant as well. So cosine and secant. Okay, very interesting. Also, something interesting to notice is that when we're looking at this, I want you guys to recall that here, your cosine is your x, your sine is your y, tangent is y over x, cosecant is going to be related to y, so it's 1 over y, and then secant is 1 over x, and cotangent is x over y. So this is how these values are found, and then everywhere that you see an NA, you could almost just write asymptote, because an NA represents an asymptote because you're dividing by 0. All right, moving on. Here's the answers for the previous night's homework. You guys can pause and check that out at your own pace here. All right, let's begin. So this is module 6.2, sign language. I want you guys to get a worksheet right now. It's page, let's see, page 9. So go ahead and hand that out. Okay, so here we're going to have to reference our little Ferris wheel that we had in 6.1. So go ahead and take that out. And we're just going to recall a couple things. Number one, that the Ferris wheel was invented in 1893, and also by that guy George Washington, not the president though, George Washington Ferris. And we also remember that the radius that was given last time was 25 feet, and from the center of the Ferris wheel, it was 30 feet above the ground. So we know that from the center here all the way down to the bottom, that was 30 feet, and we were able to figure out all the different heights using trig. So now what we're going to do is we're going to consider this. We're going to say, all right, well, given this information, if the Ferris wheel makes one complete rotation counterclockwise every 20 seconds, so that means that if you're starting at position A, it's going to take you 20 seconds all the way to go back to position A. So let's try to think about this for a minute. How long would it take then to get over here? So if it takes 20 seconds all the way to get around, how long would it take just to get to here? And yeah, okay, so this would be 10 seconds, all right? And then if it was to be like right here, okay, if halfway of the 10 seconds, this would be, well, 5 seconds, right? So what I want to know is how long will it take just to get up to position B? How many seconds? And surely we could think about this a little bit and know that if this is 360, if we divide, like let's say we have 20 seconds and divide it by, we have, how many spots? We have 1, 2, 3, 4, 5, so 5, so 10. Then that means it takes 2 seconds per each little segment here. So after 2 seconds from position A, we're going to be to position B. Okay, and so that means that in 2 seconds, he's going to go from 30 feet all the way up to 44.7 feet. Does that make sense? All right, so go back to that paper that has the diagram of the Ferris wheel. And this is the stuff that we know. We know that right here we're at 44.7 feet. We know that this we figured and calculated last time that this is 36. Okay, so now what we want to do is we want to say, we know that it takes 2 seconds. It takes 2 seconds to get to this position. So how far are we going to be when it, let's say after 1 second? Okay, so if this is 2 seconds, then we can kind of say that 1 second would be about right here. So how do we figure this out? How can we crunch this and maybe use trig? Now look, don't just think you're going to divide this by 2. We can't divide this number by 2 because it's not going straight up. It's curving. It's arcing, okay? The distance from here to here we can't say is also half. So how can we figure this out? All right, one way of thinking about this is that if we take this and instead of being 2 seconds, we move this down to 1 second. So now what we've got going on is a line that goes like this. And before, this whole thing was 36 degrees. So if we chop that in half, then that means that this would be 18. And so then we know that this is 30 feet, and we know that whatever we get for this height right here, if we add that to 30 feet, then we'd be golden. So now we're just going to use trig. We still know that the hypotenuse or the radius is 25 feet. So how do we figure out what this value is right here, this height? Sure, we're going to use sine. So we say sine of 18 equals x, our unknown, over 25. Multiply both sides by 25, and then we're left with a decimal. And then from here, we can't say that this height right here is 7.73 yet because we have to add that to 30. So once we add that to 30, then we have the value. Now because you guys are brilliant and we have all these values around this little Ferris wheel, right? So let's pull those back up. I know that you guys, because you're so smart and freaking geniuses, that you could figure out what the height is over here. Because you know something about this little circle. It kind of works like the unit circle, that the values that you have on this side kind of reflect over here. So we know that this is also 37.7, and I'm just going to round to the 10th place, so I hope you guys don't mind. So now let's use trig. Let's just say that we were to find the value right here. We know something right now. We know that every second it goes up 18 degrees, right? So literally we could look at this and say this is 18 plus 18, which would be 36, and then plus another 18. So what is 18? 18 times 3. Because this is our formula. This is our goal here. We know that we're going to take sine, and we know that for every second it's 18 degrees. So then we're just going to multiply this bad boy by however many seconds we want to see. Okay, so that's what's going to start to formulate. And you guys are going to start to see some shortcuts here. Because after we do this, we then have to multiply by 25, right? And then after we multiply by 25, we then have to go and add 30 to it. So why don't you guys see if you can come up with this value, and you know that if you have this value, then you also got that value. All right, so I got 50.2, and that means over here is 50.2. So let's see, we've already got 1, 2, 3, 4 at 5 seconds, like we said earlier. At 5 seconds, we'd be halfway, right, from hitting over here on the 180 mark. So that means that at 5 seconds, we're going to be directly above. And so we could set up a sine equation, or what we could kind of do here is say, well, if this is directly above, that means that our radius is 25, this is 30, so that would have to be 55. All right, and you know already what I want you guys to do. I want you to go around all the way on the bottom. Go ahead and find all these values as well. Take a couple minutes. All right, so check those answers. I got 22.3 right there, 9.8, and then at the bottom is 5, and those just repeat. Now take that sheet that kind of has a chart, this one right here. And so flipping kind of back and forth between this and what we got right here, this is what I want you to do. Look at what you had for 1 second. Okay, 1 second, our calculations were, let's see if we can just kind of summarize it here. We had to take 18 and then do sine of 18 times 25, then plus 30. Something like this. And then whatever we got, that's the value. Okay, so you're just going to be looking back over here, where if I could find it, there it is. At 1 second, how did we calculate it? We did this. 25 times sine 18 plus 30 gave us the 37.7. So that's what we're going to put right here and right here. And then for 1.5 seconds, do you guys remember that formula that we used? So that formula, we had 18 times 1.5. So I want you guys in your calculator to go 18 times 1.5. Now another way of thinking about it as well is that we could maybe look at this and say, all right, if this is 18 and that's 1 second, then that means that half of this would be a half a second, right? So that would be a half second, this would be a half a second. So how much are each of those half seconds? So if this is 18, that means that this is 9, this is 9, this is 9, this is 9. Right, so a second and a half would be 9 times 3, so that's 27. So you could either do it that way, or you could just do it like this. Okay, so for each of these, you're going to go 25 times sine 18 times however many seconds. Okay, so here you're just going to literally put 2.5 times 18 degrees. That'll be what you're doing the sine of, times 25 plus 30. And you're going to go through and fill out all these values. Just take a couple minutes. And then don't forget to do your homework and finish the section for 6.2.